So throughout the chapter, we've been talking all about systems of equations. And in the last lesson, we talked about graphing linear inequalities. You'll recall from the first part of the chapter, when we were talking about systems of equations, there was either one solution, no solutions, or infinitely many solutions. We talked about the different classifications. And you'll recall from the last lesson that inequalities are different because there's quite a few more solutions than just the ones on a line. There's the whole shaded region that is a solution. So in today's lesson, we're going to talk about how do you solve systems of linear inequalities, not just systems of equations. So you see the learning target there. Let's go ahead and dive right in. First of all, how do we test to see if something is actually a solution to a system? Well, you test it the exact same way you test an equation. We're going to take 2, 1 in this first example, and we're going to plug the first in for x and the second in for y. In order for this to be a solution, when we plug it in, it has to yield 2 true statements. So for the first one, I'll go ahead and write 1 is less than -2 plus 4. And then I'll see if that's true. So 1 is less than 2, that's true. So far we're 1 for 1, but in order for it to be a solution to the system, it has to be a solution for both, not just one of the equations. So I'll go ahead and plug 1 in for y and 2 in for x. And notice I have 1 is less than or equal to 3. It works for the second one as well. So yes, this point is a solution for the system. Pause the video, you try the second one here. So as you can see, I didn't have to go very far in doing this solution because when I plugged 0 in for y and 2 in for x, it yielded 0 is greater than 4, which is not true. So right away, it's not a solution for the very first inequality. Therefore, it can't be a solution for the system. I don't even have to plug it in to the second inequality. So now we're going to get into how do we graph a system and how do we tell where the solutions are. So we're going to go ahead and graph these two inequalities as if we were doing them individually. So you'll notice this first one, just a couple things to keep in mind. This is less than or equal to, so this is going to be a solid line, and the other one is greater than, so it's going to be a dotted line. So the slope of the first one is 1, and the y-intercept is at 1. So I'm going to go ahead and put some points in here. And then as best I can, I'll go ahead and draw, whoops, let's undo that. I went a little bit too low there. So go ahead and draw my line back this way, straight as I can. Okay, solid line. All right, now, that would be if it was an equation, if I was graphing y equals x plus 1. But you'll notice this is y is less than x plus 1. So remember what we do when we take a test point here. We want to see if it works. So I'll plug in the origin here, okay? And I'll see if it yields a solution. So let me go ahead and plug in 0, 0 for this first one. So 0 is less than or equal to 0 plus 1. 0 is less than or equal to 1. That's true. Therefore, this side down here is a solution. So I'm going to go ahead and grab my highlighter, and I'm going to highlight this side as neatly as I can. You'll be able to do it a lot more neatly because you'll be using Notability, which you can do straight lines and such. So I highlight this side of that border line there. Okay, so that's a solution for the first one. All those, remember, anything within that shaded region is a solution for the first inequality. The second inequality, y is greater than 2. Let me change colors here. So for this one, it's a dotted line at y equals 2, because every value in the inequality yields a result of 2. And arrows at the end. All right, now, if I plug in 0, 0, there's no x value, but if I plugged in 0 for y, 0 is greater than 2 is not true, right? That means the origin right here is not a solution. And thinking logically, y is greater than 2, so that means everything above the line. Everything above the line is going to be a solution. So notice what happens here when I shade in everything above the line. Let me change my thickness, make this go faster. I don't think that changed much, but whatever. Notice there's this overlapping region right here between the two inequalities. So right here, in this area, this is a solution for the second inequality, but not the first. Down here is a solution for the first inequality, but not the second. But here is just right. All of these are solutions. So when we're talking up here, give me two solutions and two non-solutions. The two solutions, I can pick any point from this region right in here. Okay, so I could pick, say, 6, 3. So I'll go ahead and write 6, 3 as one of my solutions. And then I'll pick 8, 8, 6 would be another solution. Again, because that's from that overlapping region there. Non-solutions is anything that is not in this. You could even pick ones that are in the red or the blue as long as they're not from the overlapping section. So, like I could obviously pick 0, 0. That's not a solution to the system, even though it works for one of the inequalities, because it has to work for both of them. Okay, and I could pick, say, -8, -2. Lots of different things you could pick there. Okay, pause the video and try number 4. Remember, we graph first, and then the overlapping region is the correct one. Okay, so to graph these, you'll notice the first inequality there is a dotted line, because it's just greater than. The second one is less than or equal to. You'll also notice to solve the second one, I went ahead and put it in slope-intercept form. Just makes it easier to graph. So I put those on as if they were lines, and then I used 0, 0 for both of them since they did not go through the origin. So if you plug 0, 0 in for the first one, you get 0 is greater than 0 minus 7, which is -7. So 0 is greater than -7. Therefore, to this side of the blue line, this side here, these are all solutions. On the next one, I did 0. This would make this term 0. If I put 0 in here, that would make this term 0. So that would be 0 is less than 12. So for the red part, for the second line there, it's down below this. So therefore, notice the solutions are in this shaded region here where the two overlap. So two solutions. One solution would be 0, 0. So I can write that one down. And then maybe another solution would be, 0, -1. Doesn't really matter. Pick anything you like. For non-solutions, 10 zeros out there. It's not shaded in by anything. And then maybe I'll pick 2, 2. 2, 2 is shaded in by blue, but not by blue and red. Okay, so therefore it is a non-solution. Okay, go ahead and try number 5. Pause the video while you do it, and then hit play when you're ready to check your work. So this one's pretty standard. Everything was already in slope-intercept form, so we can just do y is less than or equal to 3. Solid line, because it's or equal to, so we're including everything along that line. And then everything south of that line is a solution because 0 is less than 3. It works. On the other one, I've got a slope or a y-intercept of 5 with a negative slope of 1. And then if I plug 0 in here, 0, 0, 0, that would be 0 is greater than 5. Doesn't work. So I shaded everything up here. And then my solutions are everything in this little triangle down here. So one of my solutions, I could put 8, 0, and then maybe 9, 2. So I'll go ahead and write those. 8, 0. And 9, 2. For non-solutions, we could put 0, 0. Again, it's a solution for the first inequality, but not both of them. And then maybe I'll put -2, 5. There we go. All right. Okay, I've got a couple more of these. Go ahead and pause the video to graph number 6 and write down 2 solutions, 2 non-solutions. Hit resume when you're ready to check your work. Okay, so this is another one where it was convenient to put it into slope-intercept form. Pretty easy to do. You just add 3x to both sides. and then divide both sides by 2, you get y is greater than or equal to 3/2 x plus 1. So for the blue line, I went ahead and put a y-intercept of 1, and then it's up 3/2 the whole way. When you plug in 0, 0, you get 0 is greater than 1. Doesn't work. So shade on the side that does not have the origin. Same kind of concept for the red there. Got a slope of 4 with a y-intercept of 3. It's got to be a dotted line. So I put a dotted line up through there as best I could. And then if I plug 0, 0 in, I get 0 is less than 3. That is true. So you're going to shade the side that has the origin. This little pizza slice here represents our solutions. Everything else is not a solution. So like 0, 0, that would be a non-solution. So I could pick, say, 1, 4 sneaks in there, and 3, 8 sneaks in there for solutions. So 1, 4, and 3, 8. We already said 0, 0 is not a solution, so we'll put that on there. And then -4, 8. Doesn't get any of the, doesn't hit in that region there. Okay, let's keep going. All right, go ahead and do this one here. It says warm up, and this says day 2, but this is just go ahead and let's just keep it rolling with the lesson. Go ahead and graph the two inequalities here and figure out the solution, and then hit play when you're ready to check your work. Okay, so just as we did before, we went ahead and just graphed y is less than x plus 2 as if it were a line, but it's a dotted line. Y-intercepts at 2 with a slope of 1, pretty standard. And then for the second one, we put that into slope-intercept form by moving the x over to the right side and then dividing both sides by 2. So I've got a -5/2 slope starting at 5 for my y-intercept, solid line. If I plug 0, 0 in here, it yields 0 is greater than 10, which is not true. So my red line, I shade this side. And this one, I get 0 is less than 2 for the first one, so that does work. So 0, 0 is a solution for the first one, but not the second. So my solutions would be within this shaded region here. 6, 4, we talked about special cases. Is that learning target there? That was when you had parallel lines had no solution, or when two lines coincided, you had infinitely many solutions for a system of equations. When you're doing inequalities, having parallel lines, it's not necessarily true that there are no solutions. So let me show you what we mean by that by you graphing some of these. You'll notice like number 1, the slopes are the same. They're both -2. Number 2, the slopes are both 4. Number 3, the slopes are both 3. So go ahead, let's look at number 1 first of all. So go ahead and pause the video, go ahead and graph these, and then we'll talk about what the solutions would look like here. Okay, so you notice on here, when you put 0, 0 in for the first one, you get 0 is less than -4, which is not true. So for the blue one, I have to shade this way for the first inequality. For the next inequality, I put it in, I get 0 is greater than 5. Well, that's not true either. So 0, 0 doesn't work for that one either. So 0, 0 is in this region right here where there are no solutions. You'll notice there is no overlap between these two inequalities because they're both moving away from each other. Okay, so this one would be no solution. Okay. All right, so that's an example of a system of inequalities that has no solutions. Go ahead and graph these from number 2. Go ahead and unpause when you've completed graphing these. Okay, so on this one, when you plug 0, 0 in for this, which is this blue line here, you get 0 is greater than 6. Not true, so we shade to the left of the blue line. On the second one, I get 0 is greater than -5. That is true, so we also shade to the left of the red line. Notice these two inequalities overlap, except for this little strip right here, but still they have all these solutions in common. So even though they're parallel lines, there still are a lot of solutions to this inequality. All right, one more to look at here, and then we'll look at a word problem after this is done. Go ahead and graph these two inequalities, and then we'll look at what kind of solutions we have there. Pause the video and then resume when you're ready to discuss. So on this one, you'll notice for the blue line, 0, 0, this is the blue line here, so this is the y is greater than 3x minus 2. 0 is greater than negative 2, so 0, 0 works for this one, so I shade the blue line this way. For the red line, I get 0 is less than 6, so I shade the red line this way. You'll notice there's this overlap here. The solutions are in between. So zooming back out and looking at all three, when lines are parallel, you could either have no overlap like we have here. We could have one totally overrunning the other one and overlapping almost completely here. Or we could have just this little overlap between the two parallel lines. Okay, so that's just to say, if you see parallel things with equal slopes, don't just assume there's no solution. You have to go ahead and graph them when it's inequalities. Let's go and look at a word problem. Okay, so we're going to set up the system of inequalities. And then I'm going to have you graph them and check where it says list two possible combinations. That's two possible solutions. I'm going to have you check that with your teacher. So here's the question. At our party, Alice is serving pepper jack cheese and cheddar cheese. She wants to serve at least 2 pounds of each. Alice wants to spend at most $20 on cheese. Show and describe all possible combinations of the two cheeses Alice could buy. And then list two, okay? So first thing we want to do is we want to define our variables. So x equals, okay, so we're looking at, we're looking at how many pounds. Well, she wants 2 pounds. So we're looking at how many pounds of each. So x is going to be pounds, oh, my handwriting's here horrible, of, let's call x pepper jack, PJ. And y we'll call pounds of CC, cheddar cheese. Okay, she wants, here's what it says, she wants at least 2 pounds of each, okay? It also says she wants to spend at most, okay, there's a little indicator of inequality, at most $20. You notice pepper jack is $4 per pound and cheddar is $2 per pound. So one of these inequalities we could write, well, if she buys X pounds of pepper jack and it's $4 each, well, that would be 4X. And if she buys Y pounds of cheddar for $2 each, that would be 2Y. So one of these inequalities I got to write would be 4X plus 2Y has to be less than or equal to 20 because it can't go over 20. Okay, she wants to have at least 2 pounds of each. All right. So we've written an inequality involving the cost. Now we have to deal with the this whole at least 2 pounds of each. Well, since they're each 2 pounds, this actually turns into a system of 3 inequalities because the pounds of pepper jack has to be greater than or equal to 2. And the pounds of cheddar has to be greater than or equal to 2. So go ahead and draw a little XY. And it's no different for 3. So you're going to graph all 3 inequalities. And then where all 3 share a region, that's where you could have possible combinations of pounds of cheddar and pounds of pepper jack. Go ahead and try it. Check your solutions with your teacher. And while you're waiting to have those checked, obviously go ahead and start the homework.